Hi students, welcome back to physics class. In this video, we will discuss about force and torque, analogy between linear and rotatory motion. Force is a physical quantity which we will observe in linear motion, whereas torque is a physical quantity which we observe in rotatory motion. Rotatory motion. Here, force is responsible for the acceleration of the body in linear motion, whereas rotatory motion, torque tau is responsible for the rotatory angular acceleration alpha of the body. The force is measured in newtons, whereas torque is measured in Newton meter. Force is responsible for push or pull force which acts on the body, whereas torque is responsible for twist or rotation of the body. Force can be expressed as product of mass and acceleration, whereas torque tau can be expressed as r bar cross f bar. Here r bar is the perpendicular distance between line of forces. Let us say F1 and F2 are two forces acting on a body such that F1 mod is equal to F2. That is, these two forces having same magnitude. Then the line of forces, the perpendicular distance between line of forces is r and their magnitude is f. Then we can write a cross product such that tau bar is equal to r bar cross f bar. Or we can write tau bar is equal to I alpha. Here I is the moment of inertia. Moment of inertia. Alpha is angular acceleration. Next, by applying this analogy, we can derive the formula for force, which is equal to F is equal to ma, and the formula for torque, tau bar is equal to I alpha. We know from Newton's second law, external force acting on a body is directly proportional to rate of change of linear momentum. Here P is linear momentum. In the same way, in rotatory motion, we can express Newton's second law as tau bar external, that is, external torque is directly proportional to dl by dt. Here L is called as angular momentum. See, there exists a analogy between these two forces, that is, these two physical quantities. By removing the proportionality, we get a proportionality constant k into dp by dt. In the same way, here also we get tau external is equal to some proportionality constant into dl by dt. Since p is equal to mv, the linear momentum in linear motion, by substituting p value we get f external is equal to k into d by dt of mv. In the same way, here the formula for angular momentum is L is equal to I omega. By substituting we get tau bar is equal to k into d into I omega by dt. Here m is constant, so we can write f external is equal to k into m into dv by dt. Here I is moment of inertia, which is analogous to mass in rotatory motion, which is analogous to mass in linear motion. So it is also constant. So we get d omega by dt. Here rate of change of linear velocity is equal to a, linear acceleration. Here rate of change of angular velocity, which is equal to angular acceleration alpha. So we get f external is equal to k into m into a, tau external is equal to k into I into alpha. When k, the proportionality constant, becomes 1, we can write f is equal to ma here, and here in rotatory motion tau is equal to I alpha. Hence there exists analogy between force in linear motion to torque in rotatory motion. Thank you.